So we've got a rate investigation happening here. We've got 3 experiments. We've got 3 different chemicals, X, Y, and Z. We've got the concentrations of each, and we've got the relative rate here. The reaction is 0 order with respect to Y, so that means that it's not affecting the rate at all. So if you double the concentration of it, let's say, then it doesn't actually affect the rate at all, because it's to the power 0 in the rate equation, so it's always equal to 1. So we can effectively ignore it. Let's do spoilers, and we can see order with respect to Y is 0, so it has no effect on the rate and can be ignored. We're going to look at experiments 1 and 2 first of all, because 1 and 2 has Z the same. So we always find 2 experiments where something is the same. We're ignoring Y because we know it's 0 order with respect to Y. So we'll look at experiments 1 and 2 where Z is the same. So what we do is we do 2 times 10 to the power of 3 for experiment 2 divided by 1 times 10 to the power of 3 raised to the power x, where x is the order with respect to chemical X, multiplied by 2 times 10 to the minus 3 divided by 2 times 10 to the minus 3 to the power y, where y is the order with respect to z. Those two are going to cancel, so 2 times 10 to the minus 3 divided by 1 times 10 to the minus 3 to the power x is 4 divided by 1, so we have the reaction rate 4 divided by 1 here. So that's 2 to the power of x equals 4. What number is that? Is it if it's a 0, then 2 to the power 0 equals 1. It's not that. If it's a 1, 2 to the power 1 equals itself, would equal 2. So it's got to be a 2. X is 2. The order with respect to x is 2. Now we're going to look at the other 2 experiments, experiments 2 and 3. Now nothing stayed the same apart from y, and we're ignoring that. So we're going to have to use these numbers, but we've got another piece of information now. We now know the order with respect to x is a 2, so we can do that. So for experiments 2 and 3, we take the 5 times 10 to the minus 4 divided by the 2 times 10 to the minus 3 raised to the power x, which we now know is a 2, multiplied by 4 times 10 to the minus 3 divided by 2 times 10 to the minus 3 raised to the power y, where y is the order with respect to z, chemical z, equals 0.5 divided by 4. Let's do some cancelling then now. This is 0.25 to the power x. 4 times 10 to the minus 3 divided by 2 times 10 to the minus 3 is a 2. 2 to the power y, and 0.5 divided by 4 is 0.125. So if x equals 2, we know that 0.25 squared equals 2 to the power y equals 0.125. That's 0.625 times 2 to the power y equals 0.125. So 2 to the power y is 0.125 divided by 0.0625, which equals 2. So y must be a 1. If it was 0, then 2 to the power 0 would be a 1. It's not that. If it were a 2, 2 to the power 2 would be a 4. 2 to the power 1 is itself, so it's a 1. Order with respect to y is 1. So we've got order with respect to x is a 2. Order with respect to y is a 0. We told that in the question. Order with respect to z, that should say. Order with respect to z is a 1. And 2 add 1 is 3. So your answer is D.